Good day, everyone. So, my topic is all about traffic flow and analysis of roads, including queuing analysis and level of service assessment. So, first is the traffic flow. What is traffic flow? It is the study of the movement of individual drivers and vehicles between 2 points and the interactions they make with one another. In mathematics and transportation engineering, traffic flow is the study of interactions between travelers, including pedestrians, cyclists, drivers, and their vehicles, and infrastructure, including highways, signage, and traffic control devices, with the aim of the understanding and developing of an optimal transport network with efficient movement of traffic and minimal traffic congestion problems. Unfortunately, studying traffic flow is difficult because driver behaviors cannot be predicted with 100% certainty. Fortunately, drivers tend to behave within a reasonable consistent range. Thus, traffic streams tend to have some reasonable consistency and can be roughly represented mathematically. Traffic flow can be divided into two primary types. Understanding what type of flow is occurring in a given situation will help you decide which analysis methods and descriptions are the most relevant. The first type is called uninterrupted flow. No external interruption, primarily on freeways. So this type of traffic flow is the flow of traffic in which there is no obstructions to the movement of vehicles along the road. Freeway is one example for this type of facility. In a freeway, when a vehicle enters a freeway, there is no need for the vehicle to stop anywhere till it leaves the freeway. And the second type is called interrupted flow. External interruptions exist. Most frequent are signals, stop, or yield sign. So in this type of traffic flow, the flow is regulated by an external means, such as a traffic signal. Under interrupted flow conditions, vehicle-to-vehicle interactions and vehicle-to-roadway interactions play a secondary role in defining the traffic flow. To better represent traffic flow, relationships have been established between the three main characteristics. The first is flow, density, and the third one is velocity. These relationships helps in planning, design, and operations of roadway facilities. So there is a diagram here and it is called time-space diagram. Traffic engineers represent their locations of a specific vehicle at a certain time with a time-space diagram. This two-dimensional diagram shows the trajectory of a vehicle through time as it moves from a specific origin to a specific destination. Multiple vehicles can be represented on a diagram, and thus certain characteristics such as flow at a certain site for a certain time can be determined. So, flow and density. Flow, or the Q, the rate at which vehicles pass a fixed point, or the vehicles per hour. T measured is equal to the average measured time headway. So the formula for this for flow is Q is equal to 3600 N over T measured. So density or the concentration or the small k, number of vehicles or the capital N over a stretch of roadway or the capital L in units of vehicles per kilometer. So the formula for density is equal to K is equal to N over L, where N is equal to the number of vehicles occupying a highway segment of length L, and the Q or the density is equivalent hourly flow, and the letter L length of roadway, and the small k is equal to density. Speed. The measuring speed of a traffic is not as obvious as it may seem. We can average the measurement of the speeds of individual vehicles over time or over space, and each produces slightly different results. So the next one is time mean speed. Time mean speed, arithmetic mean of speeds of vehicles passing a point. So that's the formula for time mean speed. So the next is the space mean speed. Space mean speed is defined as the harmonic mean of speeds passing a point during a period of time. It also equals the average speeds over a length of roadway. So the next one is relating time and space mean speed. Note that the time mean speed is average speed past a point as distinct from space mean speed, which is average speed along a length. So the two speeds are related as Vt, segment Vt is equal to segment Vs, or the space mean speed, plus the theta squared s over the segment of Vs. The time mean speed higher than the space between space mean speed, but the differences vary with the amount of variability within the speed of vehicles. At high speeds or the free flow, differences are minor, whereas in congested times, they might differ a factor. So the next one is the headway. The following definitions give what is referred to as the brutto gap or the asella or the Italian for gross. In contrast, the netto gaps, Italian for net, netto gaps give the distance or time between the rear bumper of a vehicle and the front bumper of the next. So the next is the time headway. Time headway or the H sub t is equal to difference between the time when the front of a vehicle arrives at a point of the highway and the time the front of the next vehicle arrives at the same point in seconds. Average time headway or the segment H sub t is equal to average travel time per unit distance or the average space headway. Segment H sub t is equal to segment t times or multiplied by the segment H sub s. Space headway. Space headway is H sub s is equal to difference in position between the front of a vehicle and the front of the next vehicle in meters. Average space headway or the segment H sub s is equal to space mean speed times average time headway. So the formula is the segment space headway is equal to the segment Vs multiplied with the segment average time headway. Note that the density and space headway are related. K or density is equal to 1 over the segment average space headway. So let's move on the queuing theory. Queuing theory is a powerful tool to analyze the daily phenomenon of waiting in line. Discover how to define queuing theory, how it started, why it's important, and how it can be applied to real life situation. Queuing theory can be used to analyze the flow of traffic on the approach to and through an interactions controlled by a traffic signal. This is accomplished by analyzing the cumulative passage of vehicles as a function of time. The queuing diagram for interrupted flows shows the flow on one intersection approach. So traffic is stopped from time or T1 to T2 during the red signal interval. At the start of the green interval or the T2, traffic begins to leave the intersections at the saturation flow rate and continues until the queue is exhausted. Thereafter, the departure rate or the D times T is equal the arrival rate or the A times T until T3, which is the beginning of the next red signal. At this point, the process starts over. So, what is queuing theory? Refers to the mathematical study of the formation, function, and congestion of waiting lines or queues. At its core, a queuing situation involves two parts. Someone or something that requests a service, usually referred to as the customer, job, or request. Someone or something that completes or delivers the services, usually referred to as the server. To illustrate, let's take two examples. When looking at the queuing situation at a bank, the customers are people seeking to deposit or withdraw money, and the servers are the bank tellers. When looking at the queuing situation of a printer, the customer are the requests that have been sent to the printer, and the server is the printer. So this is the diagram. So queuing theory scrutinizes the entire system of waiting in line, including elements like the customer arrival rate, number of servers, number of customers, capacity of the waiting area, average service completion time, and queuing discipline. Queuing discipline refers to the rules of the queue. For example, whether it behaves based on the principle of first in, first out, last in, first out, prioritize, or serve in random order. So, how did queuing theory start? Queuing theory was first introduced in the early 20th century by Danish mathematician and engineer Agner Krarup Erlang. Erlang worked for the Copenhagen Telephone Exchange and wanted to analyze and optimize its operation. He sought to determine how many circuits were needed to provide an acceptable level of telephone service for people not to be on hold or in the telephone queue for too long. He was also curious to find out how many telephone operators were needed to process in a given volume of calls. So his mathematical analysis culminated in his 1920 paper, Telephone Waiting Times, which served as the foundation of applied queuing theory. The international unit of telephone traffic is called the Erlang in his honor. Telephone exchange operators in Australia image via Reddit. So this is the picture So what are the different types of queuing system? So the queuing nodes are classified using the notation. So where A is the arrival process, S is the mathematical distribution of the service time. So C is the number of servers, K is the capacity of the queue omitted if unlimited, N is the number of possible customers omitted if unlimited. So D is the queuing discipline, assume first in first out if omitted. So why is queuing theory important? Waiting in line is a part of everyday life because as a process it has several important functions. Queues are a fair and essential way of dealing with the flow of customers. When there are limited resources, negative outcomes arise if a queue process isn't established to deal with overcapacity. So the fifth is, what are the application of queuing theory? Queuing theory is a powerful because the ubiquity of queue situations means there are countless and diverse applications of queuing theory. Queuing theory has been applied, just to name a few. So the first is telecommunications, transportation, logistics, finance, emergency services, computing, industrial engineering, and project management. So let's move on to the last topic. So the level of service assessment. Level of service assessment or level of service or loss is qualitative measure used to relate the quality of motor vehicle traffic service. Loss is used to analyze roadways and intersections by categorizing traffic flow and assigning quality levels of traffic based on a performance measured like vehicle speed, density, congestion, etc. In a more general sense, levels of service can apply to all services in asset management domain. So the following sections pertains to only North American highway or laws standards. So the first is A. Free flow. Traffic flows at or above the posted speed limit and motorists have complete mobility between lanes. So the letter B is reasonably free flow. Laws A speeds are maintained within the traffic stream is slightly restricted. The lowest average vehicle spacing is about 330 feet or 100 meter or 16 car lengths. Motorists still have a high level of physical and psychological comfort. So the letter C is stable flow. At or near free flow. Ability to maneuver through lanes is noticeable, restricted, and lane changes require more driver awareness. So letter D is approaching unstable flow. Speed slightly decrease as traffic volume slightly increase. Freedom to maneuver within the traffic stream is much more limited and driver comfort levels decrease. Unstable flow. Operating at capacity, flow becomes irregular and speed varies rapidly because there are virtually no usable gaps to maneuver in the traffic stream, and speed rarely reach the posted limit. So force or breakdown flow. Every vehicle moves in a lockstep with the vehicle in the front of it, with frequent slowing required. Travel time cannot be predicted, with generally more demand than capacity. A road is a road in a constant traffic jam is at this loss because loss is an average or typical service that rather than a constant state. For example, a highway might be a loss at loss D for the AM peak hour, but have traffic consistent with loss C say some days, loss E or F others, and come to a halt once every few weeks. Most design or planning efforts typically use service flow rates at loss C or D to ensure an acceptable operating service for facility users.
Types of pavement and its design. So first is I'll tackle about the design principles, pavement components, and the role and design practices of flexible and rigid pavement. So these are the type of pavement. So the first one is a flexible pavement and the rigid pavement. So in these types of pavement, mostly they are same na sila or similar composition. So like in flexible pavement, it's just use of the sub base mga base course or the asphalt image siya sa asphalt or asphalto. So and the rigid pavement is concrete ni siya, made of concrete materials. So but mostly ang gigamit nini is they are siya kanang same na siya or parehara. So well load distribution. So siya importante kay siya sa pag ang pavement kay ang atong kinahanglan i-compute ang unsay maximum capacity anang kalsada kanang to ensure the safety or kanang mas muligon or mas mo long last ang kanang gidugayon sa kalsada. Kay like kung ang capacity ana mora ng gibugaton man nay tayo nga moagi ang mas bugat pa na yung capacity, so mas maguba, so dali ra kay di kay kwan siya kanang gasto na sad. So well load distribution. So ang pagkuan sa distribute sa load sa wheel mo na siya kanang na siya pattern nga kung say iyahang what we call that kanang kuan sa murag igo sa gibukaton sa wheel. So dapat kanang dapita or kanang part sa kalsada is kuan siya kanang ligon or so this is the kuan flexible and rigid. So kuan siya kanang differentiate. So layers in flexible pavement. So these are the layers. So mostly muna ang standard layer pero ato makita ron is kuan na kayo kanang nipis as kuan diri makita na diri ang first is the natural subgrade, then gisumpay na siya compacted subgrade. So mas then granular sub base. So mas ligon siya kung kini jud tanan man mostly sa atong makita karon sa kasada kay nipis ra kay siya kay siguro gi-corrupt sad pero mo jud ang standard na siya ang una natural subgrade, then compacted subgrade, granular subgrade, unbound subgrade, niya pang asfalto. Butang mo ni sa kuan siya flexible pavement. So joint plane concrete pavement, so lahi sa ni siya kanang inabutan ay sa joint plane ano yang sa iyang CC pavement. So here is the table of the properties, the flexible and rigid. So kana siya kanang iyang bata kalahian nilang duha sa types of pavement. So in design principle, ang flexible pavement is empirical method based on load distribution characteristics on the components, and in rigid, design and analyzed by using an elastic theory. So materials used in flexible pavement is granular materials, while in rigid is made of cement, concrete, either plan, reinforced or pre-stressed concrete. So in flexural strength, low, ang flexible pavement is low and negligible flexible strength. So mas kuan na siya dili kay siya lig-on. Gumabo iyahang flexible, while in rigid is associated with rigidity or flexural strength or slab action. So the load is distributed over a wide area and subgrade soil. So mas lig-on ang rigid sa in terms of flexural strength. So in normal loading, elastic deformation, so may elastic siya, while ang rigid is action on beam and cantilever. Sa excessive loading, local depression, so mo kuha na siya kanang mo depress siya or mulo kanang like to say mo laom, while in rigid one mo construct o cracks kanang moliki siya. So mo na yung kalayanan nila duha sa excessive loading. Sa stress, transmit vertical and compressive stress on lower layers. Rigid is tensile stress and mo na ang mga stress nga mo sidat kanang ma sa lang ilang masinati or ma encounter sa sa kalsada, like that, sa mga maagi or sa mga sakyanan, buses, transporters. So, sa design practices, flexible is constructed in number of layers, like mas daghan siya layers ang sa flexible kay napa siya subgrade, then granules, mas daghan niyang gamiton para mas malig-on, while in rigid kuan siya ang yang mostly is laid idlab it's still reinforcement. So kuan siya kanang porma ra ang iyang kinahanglan or design para mapurma siya. So na siya kanang mga slab nga gamit ra para mapurma ang iyang kalsada. Sa temperature, no stress is produced, so wala siya kuan na mo produce. Pero sa rigid siya layers ang kuan sa flexible kay napa siya subgrade, then granules, mas daghan niyang gamiton para mas malig-on, while in rigid kuan na siya ang yang mostly is laid idlab it's still reinforcement. So kuan na siya kanang porma ra ang iyang kinahanglan or design para mapurma siya. So na siya kanang mga slab nga gamit ra para mapurma ang iyang kalsada. Sa temperature, no stress is produced, so wala siya kuan na mo produce. Pero sa rigid, stress is produced kay mas kung bugnaw ang temperature anang lugar nga inyong masahan, mas dugay siya, mas dugay mo gahi or mas hinay ang iyang compressive strength or mas madugay siya ang iyang pagkagahi. So para mas mapik ang temperature. So, force of friction, less deformation in the subgrade is not transferred in the upper layers. So friction force is high in rigid. open to traffic, so road can be used for traffic within 24 hours. Road can be used until 14 hours. Like saan mostly as we have observed in the cities, wala jud sila kay ni gamit og rigid dito kay it can cause traffic, magbungkag sa kalsada, cause ang kay traffic. Mostly ang ilang gigamit is kining flexible, kay flex ra siya, flexible kaya from the word flexible itself, kay mo pwede na inigbutang inihimo ng pagbutang sa asfalto, pwede na siya maagian kay di na siya mo less deformation man, dili kay siya mo deform yun, mo mas agian siya, mas mugahi, mas mulig-on siya. Like sa kuan rigid, it needs kuan pa siya 14 days of curing, kinahanglan pa siyang pagahion pag may para mas mulig-on, kay kung di mabot pa ng specific time na gamiton na, so possibility kuan siya mas muguba, dali ra kay maguba. So surfacing is rolling or surfacing is needed, while in rigid, rolling or surface is not needed din sa kinahanglan ni road. Kay mostly in flexible gamitan na ni siya kuan like kanang mga pison or yung gamit para i-rolling na siya para compact na kayo, malis mulig-on mundo, ta pwede na siya again. Like sa rigid, mostly kuan na siya, wala sagdaan ni portang sa masahan sa forma, sagdaan na siya until ang iyang curing time human, until makuha na siya malig-on. Next, this is the load distribution. Sa flexible, kuan ra iyang load is paubos, about si sa imo sa slide ang iyang load kuan na siya kanang gamay ra kay ang distribution kanang murag kuha sa dapit ang load ni kuan dito ra sad imo dako. Like sa kuan rigid, wide, mas kuan na siya kanang kuan siya kanang katag iyang distribution sa load. Like sa imo sa nakita niyo diri ang iyang load asto nga, pero wide ang iyang distribution sa load, so dili kay siya daling maguba. Mo ni ang mostly dili kay maguba ang flexible, kay kung nadara dira man sad ang di man iyang distribution, kay dira man sad sa dapitan dira pud kuasa na putang ang load dira sad, so maguba din, dali ra kay maguba ang kuan, dili man gud mag mas dali ra maguba din yung flexible. Component of flexible pavements mo na yung mga component, which is the lower part is first is the kuan subgrade or the existing soil, so yuta, then i sunda na siya sa sub base course, then base course, then surface, which is the asphalt na ang last. So the function and significant subgrade properties, so first is the based on basement soil on road bed, important of structural and pavement life, should not deflect excessively due to dynamic loading, maybe infill or embanking. So this is the cut and fill section. So sa babaw mo ni ang cut, like kuan kung ang imuhang plan straight ra man nasa miagig bungtod, so cut siya, kinahanglan plan or kabgaban or kuag yuta man ang cut section, from the word means cut. So ang yuta nga agian kailangan sa kung bungtod isubay lang sa buntod, di mas kuan siya tricky na siya kaya mas delikado. So cut section siya kinahanglan sa kuan na yuta para mas di na kay siya kung angaton, di na kay angaton kay kuan man. Then ang fill section, like bung straight man nakit na kalalong, so kinahanglan siya tambakan or from the word fill ipunan og yuta. Then this next is the desirable properties of soil as a subgrade material. So first is the stability. Next is incompressibility. So the compression. The stability is the stability or the stableness of the materials. Then permanency of strength. So ang yang permanent bang kuan, dapat permanent ang strength sa materials nga gigamit. Di kay kung mo na strength niya ron, then pila ka time mo gamay ba or madako, so dili nga dapat permanent. Then minimum changes in volume stability under adverse condition of weather and groundwater, so dapat minimum yang changes. Like good drainage is on action. So subgrade performance. So first is the load bearing capacity. So this load bearing capacity is affected by degree of compaction, moisture content, and soil type. So next is moisture content. The affect subgrade properties like a load bearing capacity, shrinkage or swelling, influence by drainage, rainwater table elevation, infiltration, or pavement porosity, which can be assisted by crack or pavement. So mas makakuan din siya maka daw tuning kanang master si magbasa okay. So ang yuta nga agian kailangan sa kung buntod isubay lang sa buntod di mas kuan siya tricky na siya kaya mas delikado. So cut section siya kinalan siya kuan na yuta para mas di na kay siya kung angaton di na kay angaton kay kuan man. Then an fill section like bung straight man nakit na kalalong, so kinahanglan siya tambakan or from the word fill ipunan og yuta. Then this next is the desirable properties of soil as a subgrade material. So first is the stability. Next is incompressibility. So the compression. The stability is the stability or the stableness of the materials. Then permanency of strength. So ang yang permanent bang kuan, dapat permanent ang strength sa materials nga gigamit. Di kay kung mo na strength niya ron, then pila ka time mo gamay ba or madako, so dili nga dapat permanent. Then minimum changes in volume stability under adverse condition of weather and groundwater, so dapat minimum yang changes. Like good drainage is on action. So subgrade performance. So first is the load bearing capacity. So this load bearing capacity is affected by degree of compaction, moisture content, and soil type. So next is moisture content. The affect subgrade properties like a load bearing capacity, shrinkage or swelling, influence by drainage, rainwater table elevation, infiltration, or pavement porosity, which can be assisted by crack or pavement. So mas makakuan din siya maka daw tuning kanang master si magbasa okay. It can cause cracks in the pavement. So next is the shrinkage or the swelling. So shrinkage, swelling, and frost heave will tend to deform and crack any pavement type of construction over them. So must so flexible pavement design. So basic principle. So vertical stress or strain on subgrade, tensile stress or strain. So factors for design of pavement. So design wheel load, so static load, wheels, contact pressure, the load repetition. Subgrade soil is thickness of pavement required. Ano ka mga So now let's proceed to example of pavement design for a new bypass. So kini example ta kay para mas masabtan. So data gathered is 2-lane single carriageway. So paano siya kanang 2-lane Then initial traffic in a year of completion of construction. So kinahanglan dyan na siya sa kayo. So traffic growth rate per annum. So like so equal to 7.5%. The design life is 15 years. Vehicle damage factors axles 2.5. Then design CBR volume subgrade, so money. So distribution factor is cumulative number of standard axles to be catered in a design, so N. So it's given is distributive factors is 0.75%. The cumulative number of the standard axles to be catered in the design, so N is equal to number of days in a year, which is 365 times 1 plus 0.75 power of 15 minus 1 all over 0.075 times 400, which is ano siya, the two lane single carriageway, so muna the sum of the both direction. Then 0.75, which is the distribution factor, times 2.5, which is the vehicle damage factor. So kung ano siya muna itong mga madoubt ng sakyanan nga mo parking around that particular area, then which is equal to 7,200,000, which is equal to 7.2 MSA. So the total pavement thickness for CBR 4% and traffic 7 point, which is equal to 660 mm. So money ang kinahanglan nga, or how to say, the required thickness sa pavement para mo siya aning ining mga load or maka-survive siya in this the design life. So like for example, kung mas mutaas siya ang thickness or ang imong thickness nga gigamit or gihimo, which is 700 mm, so mas maayo, mas siya, mas durable and flexible siya. Then pavement composition interpolated from plate 1 CBR 4%, bituminous surface is 25 mm plus 70 mm. So road base is 250 mm, sub base, so mas siya kanang ang iyahang 660 mm, so tungan siya yung sub base mo na 315 mm, which is mo na nasa ground, then followed by siya the road base 250, then ang the granules, which is.
Hello everyone, I am Rebuyas, and I will going to report the failures, maintenance and rehabilitation of transportation infrastructure. So before we proceed, let us first know what are the content of this topic. First one is the highway pavements, highway failure causes, highway failure types, highway maintenance, material use, highway maintenance includes, and highway maintenance materials. So let's proceed for the introduction. A highway is any public road or other public way on land. A main road, especially one connecting major towns or cities. So we all know that highway is familiar for all of us. Kay perminti na ta makitaan everywhere na agini siya. And highway also was constructed on Long Island in New York in the United States in 1991. So first highway was constructed at New York City on United States. Next, highway pavements. There are two types of highway pavements, the flexible pavements and the rigid pavements. So when you say flexible pavements, it is also known as bituminous pavement. And when you say rigid pavements, or also known as cement concrete roads, so as you can see in the picture, ang flexible pavements kay ang iyang grading design is mostly compact siya, and also different ang iyang surface dressing compare sa rigid pavement. Nag-differ sila sa surface dressing, surface course, base course, and also sa ilang sa base. Mora ni kalian sa duha. Next, highway failure. So when you say highway failure, mostly kana ni siyang mga sayop sa pag-construct sa roads and highways na ay mga defects. Most commonly kuan ni siya kanaging magbangag-bangag ang mga karsada. Muna siya mga common highway failure or defects. So what are the main causes of pavement failures? So those are the following: rotting due to high variation in ambient temperature, uncontrolled heavy axle loads, inadequate stability, loss of binding action, poor design and fabrication. So mostly ang pinaka main cause jud aning highway failure or pavement failure kana yung poor design, dili sakto ba ang iyang actual design compare sa pag-implement sa design is dili mao. Next is highway failure types. So there are 4 types of failure that involves the pavements. So the first, cracking or the longitudinal cracks. So mostly crackings mo din siya pinaka visible nga failure nga makita nato sa kanang mga karsada, kanang liki-liki. Then next is the surface deformation or the rotting. So the surface deformation, kabantay mo ang design sa karsada is dili capable sa kanang load nga moagi, load nga kuana na, which is ang load sa makaya nga sa karsada is gamay compare sa load nga moagi sa karsada. So for example, if naay mula pa siya sa maximum force ay maximum load nga object ang moagi ana, so of course ang imong karsada or ang highway nimo ma-deform, which is kabantay mo nang murag na ay mo flat or mulubong ang iyang kana nga part kung agian sa beyond nga load ay beyond sa maximum nga loads. And number 3 is disintegration or potholes. In 4, surface defects. or bleeding. So first, cracking. So mostly cracking, there are 7 types of cracking. First, the fatigue cracking. Second, longitudinal cracking. Third, transverse cracking. Black cracking. 5, slippage cracking. 6, reflective cracking. 7, then edge cracking. So those are the pictures of those cracking. Here, maning upat. So next, surface deformation. So surface deformation or pavement deformation is the result of weakness in one or more layers of the pavement. So there are 5 basic types of surface deformation. Those are the rutting, corrugations, shoving, depressions, and swell. So here are the pictures of the following. So next is the disintegration. So disintegration is a progressive breaking up of the pavement into small or loose pieces is called disintegration. If the disintegration is not prepared in its early stages, complete reconstruction of pavement may be needed. So if the small issues are not paid attention, or dili nimutagaan sila attention, of course, as time goes by, it will need a reconstruction of a whole highway or the pavement. So it's much more problematic. So next, there are 2 most common types of disintegration. The first one is the potholes. Second one is the patches. So the potholes kani kabantay mo ng mga bangag-bangag mo na siya potholes kani. Then patches. Next is the surface defects. Surface defects are related to problem in the surface layer. There are 4 types of surface distress. The first one is raveling, second bleeding, 3 polishing, and the 4 delamination. So here are the pictures of the following surfaces distress. Next is the highway maintenance. So the function of preserving, repairing, and restoring a highway is to preserve the road in its originally constructed condition, also to provide user safety, and also to provide efficient, convenient travel along the road. So next, what are the materials used or being used in constructing highway or pavements? So these are the following materials: concrete, bitumen, asphalt, gravel, mineral filler, and tar. So those are the main or major materials being used in constructing highway. Next is the highway maintenance includes physical maintenance, traffic service activities, rehabilitation. So when we say physical maintenance, those are activities such as filling, patching, filling joints, and etc. So traffic service activities includes painting pavement markings, removing snow ice and litter o kanang mga sagbot. Then next, rehabilitation includes restoring or betterment of roadways such as resurfacing. Also, what are the types of maintenance being applied or which is applicable on highway and pavements? So first, the surface maintenance, then second, roadside and drainage maintenance, Third, shoulder and approaches maintenance. 4, snow and ice control. 5, bridges maintenance. 6, traffic services. So when you say surface maintenance, it is a periodic or the reshaping of a road surface to ensure proper drainage and traffic passage. So what are the purpose of road surface maintenance? To provide safety to users, improve road performance, lengthen maintenance cycles, reduce maintenance costs. Also, surface maintenance benefits are the following: creates a tightly packed road surfaces, reduces dust regeneration caused by the grinding action of large loads stone under traffic, and minimizes loss of road material to erosion, gives a pleasant view. Next, roadside and drainage maintenance. Clearing and cleaning of drains, reshape, regrade ditch or line drain, clear manhole and underground pipes, erosion repair. Shoulders. Obstruction wash into the shoulder should be removed. Vegetation control, reshape or regrade shoulder, surfaces to the correct level. Next, snow and ice control. So ice reduces coefficient of friction, tires and surface, makes vehicle control almost impossible. So snow from the road should be removed to reduce the chances of accidents. Next is bridge maintenance. So bridge maintenance, exposed steel work must be cleaned and repainted. Cleaning and resealing of deck joint, damage to guardrail must be repaired and strengthened. Resurfacing of deck, score around and under pliers and abutments should be removed. Traffic services, the installation of stop signs and other signs. Repair of traffic signals, pavement markings. So overall about sa failures, maintenance involving highways and pavements. So we conclude that highway pavements plays an important role in convenience, warning and direction. Also there should be better management from time to time to keep the pavements in good condition. Lastly, therefore, designing of pavements should be upgraded for better climate resistance. So that will be all. So that's all. Thank you.